welcome to the CS School. In this Python tutorial, you are going to learn that how to solve a differential equation using a SymPy package in Python. So basically, our objective is to solve this equation d2 by dx square function of x plus 4 into function of x equal to sin x, and we will have also some boundary condition to solve it, okay, using SymPy. So let's do it. Okay, so first I will import SymPy symbols. So I will import from SymPy import a star, right? It should be SymPy. Now I will define symbols. So define symbols and a function. For that I will so here x is my symbol, right? So x you can define as x equal to symbols and give a string as a x. So here x become your symbol. So if you put, you can see x is a printing. Now define function. So f, so just give f equal to function and give as f. So this will be like your function. So if you print here f, and if you put argument as a x, so it will take as a function of x. So this will define your function. Now what I will do, I will define my differential equation. So here you can put that define your differential equation as we discussed earlier. So you can give here equation equal to, and you can give say here equation and then type command. You want d2 by dx square, right? So you want this function. So give here diff diff, and then you want your function of x, right? So you want your function of x and you want to give 2 times with respect to x. So type here x and 2, right? So, and if you print here equation, so this will, and put comma 0, right? So this will print in that way. Now what you can do, you have to add in that some other variables. So you can add plus 4 into function of x, and then and your right hand should be sine of x, right? Yeah. So now this becomes our differential equations, and also we have some boundary conditions. So you can give here boundary conditions. So I can give a boundary condition as f prime. You can give say f of 0 equal to 0 and f prime of 0 equal to 0. Okay, so we have two conditions for our second order differential equations because it will have a two constants. Now this is our equations and we have to solve it, right? Now solve it using SymPy, right? So for that you need to put here solution equal to dissolve and pass your function of pass your equation, right? And then print what is solution. So here you can see that this is the solution of your differential equation, right? So this is the solution of your differential equation. Now you can see that you have two constant C1 and C2, right? So you have to determine using some initial conditions given the above, right? So for that give here boundary condition equal to, you can give here equation, and then you can here. So final solution, you can say final solution equal to, you can give here dissolve, you can give solution and then give your ICS, so which takes care of your condition for your boundary conditions, and equal to curly bracket and give your f of 0 such that 0, and then you want to give your f prime x equal to 0 equal to 0. For that type here differentiate a function of x and with respect to x, and then dot substitute x0, and this gives value as 0, right? So now run this code. What is the mistake? And okay, so you need to give your equation, not solution. Okay, so type here equation, and now it's fine. Now check it, what is your final solution. So you can check here. So this is the solution of your equation. So you can print my final solution. Okay, so here you can see that this is the solution of your equation with your boundary value, with boundary conditions, right? So this we have solved successfully this differential equation. Now suppose you want to plot it, that how your solution looks like. Okay, so for that you can type here, you can import numpy as np, and then you can import Matplotlib dot pyplot as plt for plotting, right? So and then you can define your x equal to np dot linspace. You can go from minus 10 to 10, minus 10 to 10, and 100 data points. You can define y equal to, you can define y equal to np dot sin x by 3 minus np dot your above expression, this expression, np dot sin 2x by 3, right? So you got your y and x. Now plot it simply. So plt dot plot x comma y. So here is the solution of this differential equation. You can see that this is how the solution looks like. Okay, you can give title plt dot title solution for of differential equation. So this is how it looks like, and you can also give a label plt dot x label. So this becomes your x, and similarly you can give your y label to mark it properly, and you can call it as a f of x, right? So this is how your solutions look like. So I hope you have learned that how to solve differential equation using SymPy package in Python, and how to give your boundary conditions, and how to solve it algebraically and numerically also. So here's a code. Here's my equation. Here's a solution with constant values, and then apply boundary condition to solve it.